Welcome back to College Algebra for Business. I promised you that in this video we would be looking at... I find that watching someone write out a polynomial expression can be kind of boring, especially if they're trying to fill time like I'm doing right now. So often in this video I will start writing a polynomial expression in real time, then I will stop recording, write out the rest of the expression, and start recording again so that you don't have to sit there watching me write it all out. However, if you are taking notes, that may be going too fast for you. If it is, once I start recording again and you can see the entire expression, please pause the video and put that into your notes. I promise that I will not get bored waiting for you to do that. This has been a public service announcement, and now back to your video. Complex fractions, something like this. And actually, we're going to be looking at rational expressions and complex rational expressions that look more like this. But let's take it one step at a time. First, we need to talk about how to multiply rational expressions. Let's start with this slightly simpler multiplication of two rational expressions. I start by looking to see if I have any common factors that are readily apparent. Well, I don't see any right away, but I'm going to factor as much as I can anyways to see if then I can see the common factors. Now I can see that the numerator of my first rational expression has a factor of x plus 5, as does the denominator of my second rational expression. Therefore, those two will cancel. Although that is all that I can do right here, this rational expression is simpler than the original. However, I promised you this expression. Remember how we deal with complex fractions, such as 1/3 over 1/5? We rewrite it as the fraction in the numerator divided by the fraction in the denominator, because each fraction bar actually means division. And now that we are dividing by a fraction, what do we do with that fraction? We say that, well, division by a fraction is the same as multiplying by its reciprocal, or as some of you know it, keep, change, flip. We will use exactly the same techniques on our complex rational expression. Let's make a little extra room here and rewrite our complex rational expression as a rational expression, x squared plus 5x minus 14 over 3x, which is the ratio that was in the numerator, and that is divided by x squared minus 4x plus 4 over, or divided by, 9x cubed. So that ratio was originally in the denominator. This is equivalent to our first ratio multiplied by the reciprocal of the second. So now I'm going to go through the process of factoring where I can. Now you may wonder why I didn't do this earlier. I waited until now so that I was not tempted to cancel things when they were not in their correct positions. Now that they are in their correct positions, that I have multiplied by the reciprocal of my original divisor, I see that I have an x minus 2 in the numerator and an x minus 2 in the denominator. And then I multiply straight across. Oh, wait, take a look at this. There are other things that can be canceled. There's a 3 in the denominator here, and a 9 in the denominator here, an x here, and an x cubed, which will become an x squared in the numerator. And now I can multiply straight across to get 3x squared times the quantity x plus 7 over 1 times the quantity x minus 2. This method works very well with complex rational expressions such as this. However, expressions like this one are a little more complicated. You may choose this method. Find the least common denominator of the numerator. Convert the fractions in the numerator to equivalent fractions that have that least common denominator as their denominator, or rather, denominators. So our numerator becomes x over 3x plus 6 over 3x. And then add those fractions. Then move to the denominator. Find the least common denominator. It looks like I'm going to need some more room because I'm going to convert those fractions in the denominator to equivalent fractions with the least common denominator and then add them. But we are not done. We still have a complex rational expression there, and we are trying to make this as least complex as we can. We're trying to simplify it. Now we actually want to perform the division indicated by this fraction bar or division bar. So we will multiply our numerator by the reciprocal of the denominator and see if we can cancel any common factors. Well, there's an x and there's an x. Now be careful. You might think, oh, I have a 4 here and a 20 here, but 4 is a factor of 4x. It is not a factor of both 20 and x. It has to be a factor of the entire denominator before you can cancel it. The same with the 3 and the 6. 3 is a factor of 6, but 3 is not a factor of x, so you cannot do any further canceling. We multiply straight across in both the numerator and the denominator. I have slightly changed the order, but 4 times the quantity x plus 6 is the same as the quantity x plus 6 times 4. We are done. I did remember to put in parentheses here because whenever you have a fraction bar, that acts as a grouping symbol. So if it helps you to put in those parentheses first, by all means, do it. Leave your final answer in its factored form so you are sure there is no further simplification to be done. Whew, that took a while. Let's try it a different way. We will start this similarly. We're going to find the least common denominator, but we are going to find the least common denominator of every fraction or ratio in the expression, in that entire complex rational expression. See, I was filling time there while I was writing. All right, so what is that LCD? The least common denominator of 1/3, 2 over x, and 1/4. The LCD has to account for each of those ratios. The LCD in this case is 3, because it's one of the factors, x is one of the factors, and 4 is one of the factors. So our least common denominator here is 12x. So what am I going to do with that 12x, though? That is the question. Let's move it over a little bit, get it out of the way, because I am going to multiply every single fraction in here by the least common denominator. That means I'm going to multiply 2 over x by 12 over x, and since I'm multiplying a fraction, I'm going to make that 12x over 1. Every single one of these. And when I perform the multiplication, watch what happens. In each case, my denominator cancels out. There is nothing that I can combine in my two terms that came from this term and this term. The terms in the denominator came from here and here. Sometimes there will be things that you can combine, so look for that when you're doing this. Can we simplify this? What do we need to do to see if we can simplify it? We need to factor. So let's completely factor the numerator after we have added it. And let's completely factor the denominator. Let me move this up a little bit. Let's see, 3 goes in there, 20 minus x times. Nope, nothing is going to cancel. That is our final answer. So here is the last example of dealing with rational expressions. All right, so we have negative exponents here. First thing I'm going to do is get rid of those negative exponents, but notice that in the numerator, those negative exponents are within parentheses because there is an addition sign there. We have an entire expression there, a two-term expression. Here's one term, and here's the second term. In the denominator, we have two terms. So we can't just go moving things with negative denominators from the numerator and the denominator that we currently have. However, we can look at this term and produce from that a numerator and a denominator. So what I'm going to do is reinterpret this negative exponent. This will become 3 over the quantity x plus h. And my next term will become 1 over x. Please see our section on integer exponents if you need some help with this. Note that what we have in the denominator here is 2x to the negative 2, but that 2 is not raised to the negative second power, so I can rewrite that term of the denominator this way. Okay, and finally we have 1 over x plus h. Ooh, that doesn't look much better yet. I'm going to move my board a little bit because I'm going to need some room on the left-hand side. The first thing I need to do is to find my least common denominator. So I'm just going to make a list of my denominators that I have. I have an x plus h, I have an x, I have an x squared, which is the same thing as x times x, and I have an x plus h. Okay, so factors that I have x as a factor. The most number of times it shows up is here, so I have to have x squared in my least common denominator. And then I have x plus h. It shows up once here and once here, so it has to show up once in my least common denominator. So next, I will need to take that least common denominator and multiply it by every term in my numerator and in my denominator. Okay, I was trying to do this quickly, but I just cannot resist. The reason we can multiply each of these terms by the least common denominator is because it is just like taking the entire numerator and multiplying it by x squared times x plus h, and the entire denominator by x squared times x plus h. And what is this equal to? Right here. That's equal to 1, right? We are multiplying the entire complex rational expression by 1. We just happen to be going ahead and distributing that x squared times the quantity x plus h to each term, as we've done here. And so now I can cancel some things. In fact, I can cancel this x plus h. I can cancel one of these x's. I can cancel x squared here and here. And once again, I can cancel x plus h. So now what does my entire ratio here look like? Let's see, in the numerator I have 3x squared left in the first term, and I have x plus h in the second term. That is all over 2 times x plus h for the first term in the denominator, and then I'm subtracting. I don't want to forget the negative sign, or the subtraction sign, x squared. Look at that. Now, is there anything I can combine in the numerator? No. Is there a common factor I could take out? Not of everything. So that's pretty much set where it is. And in the denominator, what's going to happen? Looks like not much else, right? So let's see how this works out. Even if I distribute, maybe I should distribute just in case. See what happens. So let me move this up. 3x squared plus x plus h in the numerator. In the denominator, I have 2x plus h, or rather 2h, minus x squared. And why don't we just go ahead and put these in the same order with descending powers of x in each term. And that would give me negative x squared plus 2x plus 2h. Because I know nothing about what h is, I cannot factor these. I am done. And this video is done. However, if you feel like you could use some review on any of the topics that we have touched on in this video, please take a look at these cards at the end of the video, and these will take you to other videos that may help you out. I'll see you in class.